Hello and welcome back to Michelle's version of calculus, and we're going to be starting unit 3, and we are starting strongly with the chain rule. Alright, chain rule is going to be your bestest friend from now on, and we use it to find the derivative of composite functions. And basically with this is, I guess let me just do a little quick example here. Use it to help you find derivatives of something that have an inside function and an outside function. Alright, so let me show you a little example. Let's say you have sine of x squared. Now, originally you were told, of course, that we know that the derivative of just regular sine x is cosine x. However, because of this lovely little x squared here, alright, this is now considered a composite function where you would use chain rule and no longer be allowed to use just your basic, your basic memorized derivatives of trig functions. And so because of this, so your outside function, of course, would be sine of x, because that's generally what this is saying. But now we have a value or argument here, or something that represents x, and we would have that, we'd represent that as g of x, and that g of x is x squared. Alrighty, let's go ahead and just erase that. Alright, so here we have, let's go straight into the definition. We have two definitions here. They're, of course, there's one on the left, one on the right. They are both saying the exact same thing. However, at least for my brain, it's a lot easier to look on the definition over here that is to our left. All right. So with this definition, it says f of u equals f prime of u times times u prime. And this is basically saying you would first find the derivative of the outside function of f of u, which is kind of the derivative of that, and then you would multiply that, of course, and find the derivative of the argument to get u prime, and you'd multiply that by each other. And the same thing is being said on the right-hand side too, just a lot more complex than it needs to be. All right, so let's go straight into our first example. So of course we're going to find the derivative of y equals sine to the third 4x, using chain rule here. A little something for you guys to go ahead and note. Just draw a little sticky note here. To note, sine 3 to the 4x can be rewritten as sine to 4x. Okay, like this, right? However, sine to the 3 of 4x cannot be rewritten as sine 4x to the third. And that's because these are saying two very different things. And you have to realize that the cubed over here is being put onto the sine and not onto the argument. Back to this lovely handy dandy example again. So we are going to write this as sine to the 4x cubed, and then we're going to use our lovely power rule here to get 3 sine 4x squared, and then we are going to multiply this by a derivative of sine 4x, and the derivative of sine 4x would require us to use chain rule here, so then you would get I'll just kind of try and break this down in a separate color. That would be broken down into a cosine. Breaking down into cosine of 4x. Ooh, let me just get more space. Okay, cosine of 4x times the derivative of the 4x here, which is that other argument derivative of that, which would just be 4. So then your total thing would kind of end up being like this. So y prime, in this case, or the derivative of this, would equal 3 sine, or I guess we can go back to 3 sine squared of 4x times cosine 4x times 4. And that would be your final way of saying or doing this. And you can technically kind of go ahead and spread out or multiply this out, I guess, better, which should turn into y prime equals 12 sine square root of 4x cosine 4x. And that's basically it for example number 1. Alrighty. Thank you. That's all for chain rule.